You know that feeling, right? You cram for a big test, you totally ace it, and then a week later, it's all gone. Poof. Well, today we're going to dive into why that happens, and way more importantly, how to build knowledge that actually sticks. We're talking about making a huge shift, moving from just memorizing stuff to truly, deeply understanding it for the long haul.
Seriously, it's a feeling we all know. You put in the hours, you get the A, and then a month later, it's like a blank slate. It's so frustrating. So, what is going on inside our brains? And, how do we fix it?
Okay, so let's break this down with a really clear example. Imagine you have to learn about a DNA strand. On the one hand, you could just, stare at a diagram in a textbook and try to memorize all the labels. But on the other hand, you could actually build a model of it, maybe with some clay and wire. These two ways of learning seem small, but they represent a massive difference in how our brains grab onto and hold information.
Now, that second approach, the one where you're actually building something, that brings us to our first key ingredient for learning that lasts. It's a really powerful idea called constructionism, and it is all about the power of doing.
So what is this fancy word constructionism all about? Well, it's a learning theory from a guy named Seymour Popper, and here's the core idea. We learn best when we are actively making real, tangible things. It's not about sitting back and just letting information wash over you. It's about getting your hands dirty and creating something with it.
And this, right here, this boils the whole theory down to its simple, powerful truth. If you really want to learn something, don't just study it. Go make something with it. It's that simple.
Okay, so let's go right back to our DNA example. When a student is physically building that model, twisting the wire, sticking on the little clay pieces, they're doing so much more than just arts and crafts. They are literally constructing that knowledge inside their own mind. The physical act is actually building the mental framework. It's pretty cool.
Now, here's where things get really interesting. The teacher's role in all of this, it flips completely on its head. They aren't the lecturer at the front of the room giving step-by-step directions. Nope. They become a facilitator. Their job is to provide the cool materials, pose the big, interesting challenge, and then get out of the way and let the learning explode.
But hold on. Doing is only half the secret sauce. To make that learning truly deep and permanent, we need to add a second, kind of magical ingredient. And that's the power of thinking, or to use the official term, metacognition.
Metacognition? It sounds complicated, but it's really just that little voice inside your head when you're learning. It's being aware of your own thinking. It's the ability to kind of step outside of yourself for a second and monitor, direct, and review what's going on in your own brain. This quote just nails it. It's the essential skill of thinking about your own thinking. It's that little voice that asks, wait, do I actually get this? Why did I do it that way? Is this even working? That right there is metacognition in a nutshell.
Let's jump back to our DNA model. Metacognition is when the student pauses, looks at their creation, and asks questions. I picked wire. Why was that a better choice than thread? My original plan was to use clay for these little parts, but it's making the whole thing sag. What does that tell me? See, it's this active layer of reflection right on top of the act of doing. And just like before, the teacher's role gets another upgrade. They're not just a facilitator of stuff anymore. They become a coach. Their whole job is to ask those brilliant, probing questions that nudge students to look inward and really examine their own logic.
All right, so we've got these two powerhouse ideas, constructionism, the doing, and metacognition, the thinking. But what does it actually look like when they join forces? Let's step inside a real physics class and see it in action. So the teacher starts with a challenge. Okay, everyone, make 3 light bulbs glow. But there's a catch. If you unscrew one bulb, the other 2 have to stay on. Immediately, the kids are messing with wires and batteries. That's the doing. But as they're working, the teacher's walking around asking these really specific questions. That's the thinking. And that combination is what leads directly to that incredible aha moment, where they don't just solve the puzzle, they finally get what a parallel circuit is. And look at the kinds of questions the teacher asks. This one is a planning prompt. Before the student even touches the wire, the coach asks them to make a prediction and say why. It forces them to stop and think, to actually form a hypothesis before they act. It's so smart. Now, this is a monitoring prompt. When something doesn't work, the teacher doesn't just give them the answer. Instead, they ask this brilliant question. Basically, what did you think was going to happen and what's actually happening right now? This helps the student pinpoint the exact spot where their understanding went wrong. And then, finally, an evaluating prompt. So after they've figured it out, the coach has them reflect on the whole journey. This is what cements the learning. It makes them walk back through their own process and identify that key moment when the light bulb literally went on. So, let's pull all this together. Let's make a simple, practical toolkit that you can actually use, whether you're a teacher, a parent, or hey, even if you're just trying to learn something new for yourself. This table is a fantastic way to see it all laid out. The doing part, constructionism, is the hands-on activity, right? Like building a whole city out of geometric shapes. And the thinking part, metacognition, is the reflection that comes after. That could be writing a quick paragraph about how you figured it out, or maybe filling out a checklist about your own problem-solving strategy. And I love this because it perfectly captures the two essential vibes of a classroom like this. You need both. You've got the noisy, active, maybe even a little messy doing phase. And then you have the quiet, thoughtful, reflective thinking phase, where all that amazing, deep understanding really gets locked in. And here it is. This is the big takeaway. If you remember one thing, make it this. Constructionism gives a student a hands-on problem to solve, and metacognition gives them the mental tools to understand how they solved it. It's the perfect, powerful partnership. And that leaves us with one last big idea to chew on. What if we shifted our whole focus in education? What if learning wasn't just a race to find the single right answer, but was really about understanding and even celebrating the messy, creative, and amazing journey we took to get there?